Alright, some more sum of the root and product of the roots examples to work with here. So let's say we have a quadratic equation expressed by x squared plus bx minus 2. So we're missing the value of b. And that has a root of 1 plus radical 3. What's the value of b? So now if we're looking for the value of b, which means we're going to have to use the sum of the roots formula, negative b over a. And we're going to say that's equal to root 1 plus root 2. Now, the problem here is that we only have one of the roots, so that means if we're looking for the value of b, we better have both of the roots, because we can't have two unknowns. We can't be missing b and root 2. So that means we have to find the other root first. So let's use the product of the roots formula, c over a equals root 1 times root 2. Well, the value of c is negative 2. The value of a is 1 equals 1 plus radical 3 times root 2. So now we just have to solve for root 2 by dividing by 1 plus radical 3. So we have negative 2 over 1 plus radical 3 equals root 2. We have an issue here. There's a radical in the denominator, so let's rationalize. And the way we'll rationalize is by multiplying by the conjugate of the denominator. So 1 minus radical 3, 1 minus radical 3. So let's distribute this. Negative 2 times 1 is negative 2. Negative 2 times negative radical 3 is positive 2 radical 3 over 1 times 1 is 1. 1 times radical 3 is radical 3. Negative radical 3. And radical 3 times radical 3 is just negative 3. And that's still equal to root number 2. Let's clean this up. We have canceling terms here, and 1 minus 3 is negative 2. So if we just bring this up here, we have negative 2 plus 2 radical 3 over negative 2 is our second root. So we can divide both of these terms by negative 2. Negative 2 divided by negative 2 is positive 1. And positive 2 radical 3 divided by negative 2 is negative radical 3. So there is our second root. Now let's take a look at this root and compare it to the first root. The first root is 1 plus radical 3. The second root is 1 minus radical 3. What do you know? They are conjugates. Yes, that will always be the case. And that is because of the quadratic formula being x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant here is 3. We're adding and subtracting radical 3. So they just separated the plus and a minus there. So yes, the other root will always be the conjugate of the first root. So now, we just did a lot of work there. But that work was simply to find root 2. The question asked us to find the value of b. So now we can plug it in. We have a value of b which is missing. We have a value of a which is 1. Root 1 is 1 plus radical 3. Plus root 2 is 1 minus radical 3. Therefore, negative b equals 2, which makes b equal to negative 2. Now, if you're unsure of yourself, because a lot of work went on here, what this is saying to you is that we have a quadratic x squared minus 2x minus 2 equals 0. And those roots will be 1 plus n minus radical 3. Find the roots. Make sure. You will get 1 plus and minus radical 3. Here's another example. Now we have imaginary roots here. A quadratic has roots of 2 plus I and 2 minus I. What could be an equation which yields these roots? So, there's a couple ways we could think about this. We could either work backwards from our solutions, or we can use the sum and product of the roots formula to yield the values of b and c. So we know that negative b over a equals root 1 plus root 2. Well, we can solve for b here if we let a equal 1. Let's say that we have a leading coefficient of 1. just to make this easier. So therefore we have negative b equals these roots being added together. 2 plus I plus 2 minus I, root 1 plus root 2. Clean this up. Negative b equals 4. So b equals negative 4. Now we'll use the product of the roots formula to find c. c over a equals root 1 times root 2. Again, we're letting a equal 1. So that means we have c equals root 1, 2 plus I, times root 2, 2 minus I. Let's FOIL these out. c equals 4 minus 2I plus 2I minus I squared. Let's substitute negative 1 for I squared. So c equals 4 minus negative 1. Therefore, c equals 5. Which means our quadratic, we said let a equal 1. So 1x squared minus 4x plus 5 equals 0. So this is a quadratic which would yield roots of 2 plus I and 2 minus I. Alright, we have a quadratic whose roots are positive and negative 3i. What is an equation that satisfies these roots? Again, negative b over a equals the roots being added together. Root 1 plus root 2. The sum of the roots formula means you're going to be adding the roots. In this case, I'm going to say let a equal 2. Why? Why not? So we're going to have negative b over 2 equals 3i plus negative 3i. So negative b over 2 equals 0, which makes b equal 0. Okay, now let's find the value of c by applying the product of the roots formula. We said let a equal 2 here. We're going to do the same thing here. Let a equal 2. That means I'm going to have something 2x squared, and then the rest we'll figure out in a minute. So we have c over 2 equals 3i times negative 3i, the roots being multiplied together. So therefore c over 2 equals 3 times negative 3 is negative 9, and I times I is I squared. Let's multiply both sides by 2 and substitute negative 1 for I within the same step. So we have c equals negative 18 times negative 1. Substitute negative 1 for I squared and multiply both sides by 2. Therefore, c equals 18. So we have a value of b of 0 and a value of c of 18. Therefore, our quadratic is 2x squared plus 18 equals 0. Last example for the day. Let's say that we have one root of this quadratic, x squared plus bx plus 18. And that one root we have is 4 plus I radical 2. What's the value of b? Well, this is telling us that root 1 is 4 plus I radical 2. This can get pretty complicated if you didn't know that the other root would be the conjugate. Fortunately, I'm smarter than that. We're smarter than that. We know that the second root will be the conjugate of the first. Therefore, the second root is 4 minus I radical 2. We're searching for the value of b. So let's use the formula which contains a b. b over a equals root 1 plus root 2. Let's let a equal 1, because a is 1. So, negative b equals root 1, 4 plus I radical 2, plus root 2, 4 minus I radical 2. Therefore, negative b equals 4 plus 4 is 8. I radical 2 minus I radical 2 cancels. So b is negative 8. That's what the question was asking for, so we're good. Just if you want to check your work, you would have a quadratic x squared minus 8x plus 18 equals 0. If you were to find the roots of this quadratic, you would get 4 plus minus I radical 2.